Okay, next we have interference of waves. In the superposition principle, we discussed three conditions. One of the condition is we say that superposition of wave superposition of let's say two waves having same frequency and the two waves and are moving with same direction in the same direction will results of the phenomena of interference. Suppose we have two waves such that both the waves have the same frequency and also they are moving in the same direction, then they will results a phenomena which is called interference. Now we will define the term interference. It is basically the superposition of double P. The superposition of mixing of waves at a particular point such that they giving rise to maximum or minimum effect or both is known as interference. Like an interference phenomena is a kind of phenomena in which two waves superpose to form a resultant wave such that the amplitude of the resultant wave is either bigger than the individual amplitude of the waves or it's smaller than the individual amplitude of the waves. So on the basis of this we can define or we can categorize it into two types. One is called constructive interference and the second one is called destructive interference. Now first I will discuss about constructive interference. If the waves so meet that their crest and trough falls on each other, such that they reinforce each other. We call this effect as constructive interference. We can picturize it. Suppose we have two waves. I will consider two different colors for two waves. Suppose we have two waves moving in the same direction, having same frequency, such that, let's suppose this is first wave, and let's suppose we have another wave which is also moving in the same direction, which I represent by this red color. These are the two waves, such that crest of both wave or the trough of both wave fall on each other. Here the crest of this wave fall on the crest of this wave, and similarly the trough of this wave fall on the trough of this wave. These two waves reinforce each other, or they can enhance the effect of each other, and the resultant wave is given like this. This is the resultant wave. Suppose we have wave 1 which is amplitude y1, and we have wave 2 which is amplitude y2, then the resultant wave has an amplitude equal to the sum of the amplitude of the two individual waves. This phenomena is called constructive interference, because the trough of both waves or the crest of both waves fall on each other, and the resultant wave, or they enhance the effect of each other. So the resultant wave amplitude is the sum of the amplitude of individual wave. This type of interference is called constructive interference. Next we have destructive interference. Now, if two waves meet such that the crest of one wave falls on the trough of the other wave, and they're giving rise to minimum effect. We call this phenomena is destructive interference. Suppose we have two waves. We have two waves such that this is wave 1 and we have another wave which is like this. Now the crest of first wave fall on the trough of the second wave. I call this is wave 1 which is amplitude y1, and I call it this is wave 2 which is amplitude y2. Now the crest of one wave fall on the trough of the other wave. the resultant effect is such that they minimize each other. So the resultant wave will be like this. This is the resultant wave. This is a resultant wave, and this resultant wave has an amplitude which is equal to y1 minus y2. Now if you look at here, these two waves are 180 degree out of phase because it start upward and it start downward. So there is a 180 degree phase difference between wave 1 and wave 2. So they give rise a minimum effect which is called destructive interference. So the resultant wave amplitude is smaller than the amplitude of the individual wave. So this is called what we call it, destructive interference. Now if you look at here, the amplitude of wave 1, which is y1, is greater than the amplitude of y2. So what if y1 is equal to y2? Like the amplitude of y1 is equal to the amplitude of y2. Then in this case, so this is the magnitude. So in this case, we have a condition like this. Suppose this is wave 1, and let's suppose we have another wave, wave 2, I call it wave 2, such that both have equal magnitude but they are 180 degree out of phase. The resultant wave will be a wave with zero amplitude. This is y1, its amplitude is y1, and here its amplitude is y2, which is equal to y1. So the resultant amplitude, the resultant wave has an amplitude y, which is equal to y1 minus y2, which is equal to 0. So this will look like a straight line. So this is also called destructive interference. Like two waves reinforce, superimpose on each other in such a way that the crest of first wave falls on the trough of the second wave, so that they minimize the effect of each other. By minimize, I means they cancel the effect of each other. So we have no waves in this medium. Such type of interference is called destructive interference. Now I will do the mathematical calculation in the next video. Thank you.